we are very glad to have the opportunity to share the research findings of our team on hacking the bugs. Today, our talk is called X in the Media, attacking faster charging pairs and electric vehicles. First of all, please allow us to introduce ourselves briefly. I'm HuiYu. I'm a senior security researcher at Tencent team. Now, I'm mainly focusing on IoT security research. I'm also a bug hunter, winner of Kibam, and speaker of blackhat.com, hacking bugs, Catalyst, and POC. And the other is my teammate, YuXiang. He is also a senior security researcher at Tencent team. Now he is focusing on mobile security and IoT security. He reported multi-temporal vulnerabilities of Chrome and Android. He also was speaker of blackhat.com, Catalyst, hacking bugs. And Tencent team was funded by Tencent Security Platform Department. Now we are focusing on security research in the areas of AIoT and cloud visualization. We have reported more than 200 vulnerabilities to vendors such as Google, Apple, Microsoft, and Amazon. And if you want to know more about our team's research, you can visit our blog. Let's move on to today's topic. Our talk is mainly divided into 4 parts. The first part, we will introduce the electric car charging technology and standard. The second part, we will analyze the attack surface of electric charging. In the third part, we will introduce what is X in the media attack. And finally, we will introduce how we attack the plug and charge technology in the real world. As everyone knows, very rapid expansion of electric car market has promoted the construction of charging infrastructure. DC charging is the main charging technology in the future. It has higher charging power, and in order to convert the charging voltage and current, the electric vehicle and the charging station will communicate after being connected to complete the handshake. There are different charging standards in different countries. For example, an electric car in China must support the GPT standard. Electric car use CAN bus to communicate with the charging pairs, where in most parts of Europe, CCS standards are used, and electric cars and charging pairs use PLC to communicate, with the exception of Tesla, who has its own supercharger network over the world. It uses a private communication protocol. In addition, we also want to talk about why we choose to study the electric charging security. The main reason is that we found the electric vehicles infrastructure is making progress towards a more intelligent, more high-power direction. The construction of the charging station is accelerating all over the world, but there is little research on the security of electric vehicle infrastructure. In following section, we will briefly analyze the attack surface of electric vehicle charging. First of all, EV charging pairs are also IoT devices which usually have built-in system and operating interfaces. We are facing security risks in hardware, systems, cloud service, and communications. But our focus is on the security of the communication protocol between the electric vehicle and the charging pair. This will be a new and interesting exploration. The following picture shows the process of charging a car at a DC charging station. Charge control communicates with the EMS before charging to confirm the parameters such as charging voltage and current, which involves a lot of data exchange. So if we can implement a man-in-the-middle attack, we may be able to find the vulnerabilities in BMS and charging control through buzzing. Or we can analyze private protocol and bypass identity authentication mechanism. Or we can damage the car by tampering with the charging voltage and current. Next, we will show the section about X-in-the-middle attack. First, we will talk about its architecture. Then we will talk about the challenges and the solutions we encountered in the testing process. And finally, we will share the quick test conclusion on Tesla supercharger. In order to conduct security testing safely and conveniently, we have designed a tool called XCharger. The core of XCharger is a data processing terminal based on HTML, MCU, or Raspberry Pi, which isolates CAN-bus message from BMS and the charging pairs. All CAN-bus messages cannot be transmitted normally until they are transferred through XCharger, which allow us to monitor fuzzing and temporary CAN-bus message in whole charging process. Another feature is that we designed the whole tool into a 20-inch suitcase, which has two charging sockets. One is connected to the charging pair, and the other is connected to the electric vehicle. And the high voltage current is directly connected, and only for CAN-bus communicate interface are exported to ensure the high voltage safety. Next, let's talk about why we do this and the challenges we face. When we do security research, the most important thing is that it should be able to ensure the personal safety and the vehicle safety. DC charging can reach a voltage of up to 750 watts or a current of 120 ampere. Once a short current occurs, is very dangerous for the test and the car. Secondly, we hope the attack equipment should be highly compatible, suitable for all electric vehicles with Chinese DC charging standard. Instead of requiring customization for each brand of electric cars or charging pairs, we also find the CAN-bus communication requires low latency and man-in-the-middle attacks needs to ensure the brains will not be dropped. We rented a Tesla Model 3 for testing, and we found that its charging port exported the CAN-bus interface with a separate plug, which means that we may be able to disconnect the origin connection in the trunk to achieve a man-in-the-middle attack. But the problem is that may lead to the net damage, which doesn't seem suitable for such an operation on a rented vehicle. In addition, We have also thought about transforming Tesla's GBDC adapter for packet capture, but we believe that these also have a security risk, and this doesn't apply to other vehicles. A perfect solution we have given is the equipment shown below. You can see that it has two charging sockets. One end is connected to the electric vehicle, and the other end is connected to the charging connector. The CAN-bus interface of BMS and the CAN-bus interface of the charging pair are all exported on the surface. And at the same time, we have customers dual plug charging cable to connect the equipment and the car. This equipment is designed by us and made by professional vendors in Shenzhen, China, which can ensure the safety of high voltage power use. There are many open source tools available for CAN-bus, the mandatory, fuzzy, and temporary. To use both Raspberry Pi and two-way CAN extension boards. We can use Python to develop a testing framework on the built-in Ubuntu system. And due to the limited time, we will release more details and code in the future. We use XCharge to do a quick test on Tesla Supercharge in China, and the test results verify that the device can capture the messages successfully, but we do not have any more tests because we do not have the DBC file to translate the CAN-bus message. We found that some of the message in CAN-bus communication between Supercharger and Model 3 use private protocols, and some message conform to the GPT standard. When testing with Model 3, there are a high probability that it will not be able to charge successfully. The reason is still being analyzed. If you want to reverse the complete protocol, it may be a better choice to analyze the firmware of BMS or Supercharger. In addition to the Tesla Supercharger, we spend more time in public charging stations. In the following part, we will share how to attack the plug and charging technology in public charging stations in China. First, we will introduce the principle of plug and charge, and how to use XCharge to attack it to achieve free charging. Finally, we will give some security advice and briefly analyze the future trend of charging technology. Plug and charge is a new way of automating payment for EV charging. Users do not need to swipe their cards or scan codes. Just connect the charging pair to the vehicle charging port to automatically complete the identity authentication and payment. For electric vehicle companies that build their own charging pairs, such as Tesla, private communication and authentication protocol can be used to ensure the security of plug and charge. And there are different implementation of plug and charge. The plan A is to install a camera near the charging pair to verify the vehicle license plate for authentication. The plan B is to install a RFID tag at the position of the electric vehicle charging circuit and read the target content for authentication when the charging gun is connected. And plan C is the SDK provided by charging pair operator is built into the intelligent system of electric vehicles, and the authentication is automatically completed when the vehicle reaches the charging station and opens the charging cover. And the last plan is the vehicle's VIN number is transmitted for authentication during the charging handshake process. Considering the capability and cost, some public charging station operators have chosen to use VIN to complete vehicle identity authentication on basis of GBT standard. Operators do not realize the VIN is not a security authentication in an insecure campus communication. GBT standard is the Chinese standard for electric vehicle battery charging. Cable charging standard GBT is based on SAE and uses the campus with a point-to-point connection between the charger and the battery management system. A transmission rate of 250 kbits per second is used by default. Charging communication involves both BMS and charging control. With the GBT protocol, communication is divided into following parts during the charging process. In the handshake recognition, the charging connection check is completed and general information such as protocol vision and vehicle information. For example, the battery temp, vehicle identification number, and so on, is changed. What we are most concerned about is that during the handshake, the BMS will transmit the VM number to the charging pair. After actual testing, we use contours and the GBC to successfully translate all messages during the charging process. We found the BMS of electric vehicle transmitted the vehicle's VIN to the charging pair for identity authentication in the BRM message during the handshake recognition. The following is the complete plug and charge the architecture. First, the car owner needs to register and bind the vehicle's VIN number on charging pair operator's application and activate automatically payment. Secondly, when the car owner is charging, he only needs to directly plug and charging gun into the electric car to charge. The charging pair will upload the VIN transmitted from the BMS to the operator's cloud server, and the operator will query and return the user's credence corresponding to the VIN in the background database. After the charging pair receives the user's credence, it will start charging and automatically pay at the end of the charge. Weaker authentication number is a unique code, including a string number used by automotive industry to identity and diversion weakers. The biggest problem is the VIN is a public plaintext information with specific coding rules and can also be obtained from the front windshield of the car. In order to configure the attack script quickly, we have written a tool that it means the function includes the temporary of VIN, charging voltage, and current. It also supports the BMS simulation so that we can test the charging pair without a weaker. The following is the ruler of exchange in the attack process. It can hijack the message between the car and the charging pair. In order to verify our tools in the real world, we rented 5 electric cars of different models and tested multiple charging stations that support plug and charge. We verified that after obtaining the VIN on the windshield of the vehicle, the charging pair can be successfully attacked by X-Charge to achieve free charging. And now all of the vulnerability we found have been notified to the vendor and fixed. Okay, my part is over. The following time will be shared by my colleague YuXiang. Thank you.
Thanks. I will continue to share the following part. In this part, I will give some security advice and introduce some of the latest charging standards. But charging piles operators can deploy a risk control system to crack off battery information, such as battery type, capacity, manufacturers, product status, battery pack serial numbers, numbers of charge, transmit during the charging handshake process of vehicles that use the plug and charge function, and generates the corresponding electric vehicle's fingerprint information. Since the attacker cannot know the detailed battery information of the target vehicle in advance, simply tampering with the VIN cannot pass the fingerprint information verification, and the risk control systems can accurately detect the attacks and block it. The first plain advantage is low cost, no need for additional hardware modification, and its disadvantage is because parts of the battery information, such as battery pack serial number, charging times, is an optional transmission items in GBT 27930, and part of the battery information of a specific models is public. So the risk control systems may not be able to crack enough information to ensure security. For the two-way authentication scheme, charging pile operators need to cooperate with electric vehicles manufacturers to ensure security. This may require adding a public key transmission function to the vehicle's BMS firmware or implementing a NIFEL's communication function between the vehicles and the charging pile, or use a specific provide protocols for communication. Advantage: very secure. You can mitigate mitigate the risk of middle attacks. Disadvantage: high cost, not compatible with all vehicles. According to the next generation charging standard HuiYu, dominated by China and Japan, will be officially released. It is improving the security of communications and identity authentication. HuiYu charging support plug and trust, V2X, and other new technology applications. Some of the security risks mentioned in our talks may be resolved. In addition, we also see another new standard, ISO 15118. It is a standard for vehicle-to-grid communication. Use symmetric encryptions and digital signatures to ensure the security of communication between electric cars and charging stations, and supports plug and charge. It uses PLC communications, which is mainly used in Europe. Through the discussions of these trends, we are very happy to see that security has become a must be considered in these standards. We believe that in the near future, when these new technologies and new standards are applied in the real world, they will promote the security developments of the entire electric vehicles charging industry. Okay, that's all. Thank you for listening. And if you have any questions, you can contact us by this email.